Hi, this is Tim, and I'm doing video 2-2 momentum. I chose problem number 13. Two blocks of massless M and 3M are placed on a frictionless, that'll be important, so I highlighted it, frictionless horizontal surface. A lead spring is attached to the more massive block, and the blocks are pushed together with a spring between them, as shown in the figure below. A cord initially holding the blocks together is burned. After that happens, the block of mass 3M moves to the right with a speed of 2.7 meters per second. Here's the photo. We've got a spring and a string and a spring. Spring is broken, and then we have our two blocks going in opposite directions. Whoops. So part A asks, what is the velocity? Oh, that's aggravating. What is the velocity of the block of mass m? Assume right is positive and left is negative. So after that, I decided to set up a momentum bar graph. So in this first part, there is no movement, no speed, so therefore there can be no momentum. So our system's at rest. And then post release, when the spring is cut, we have momentum in the right direction, momentum in the left direction. Since block M is lighter, block M is lighter than block 3M, we know that momentum equals mass times let me make that a little bigger. Momentum equals mass times velocity. We know that the speed of the orange block will be greater. So from this, I decided to set up an equation down here, and then before we get to that, I'll just list off, given M of orange block 3M, M of blue block 3M, what kind of collision is this? I said elastic because momentum as well as energy is conserved. You might say, how do you know that energy is conserved? Well, we know that the, oops, let me end that, thank you. We know that the elastic energy in the spring is going to be transferred to kinetic energy once the string is cut. So this is just kind of for fun or kind of for your understanding, but we know that the elastic energy will equal the kinetic energy in block 1 and block 2. So here's that equation I was talking about from the momentum bar graph. So 0 equals 3m times 2.7 meters per second plus m. This doesn't represent like the symbol for mass, but it is m because they gave that to us. And then velocity, the second velocity. So we just solve that, and then we get negative 8.1 meters per second. And I plugged in the website, everything's good, so moving on to part B. Part B asks to find the system's original elastic potential energy, taken m equals 0.36 kilograms. So we're going to set up a kinetic energy equation. I listed the given of the mass. So a common mistake you might make is assuming both blocks will have the same amount of energy, and that would be true if this was the equation solved for kinetic energy. However, we know that the equation is k equals 1/2 m velocity squared. Squared is very important. Speed is very important. You can set up an LOL if you'd like. I didn't really see a big purpose in it. I think LOL is kind of unnecessary here. You really don't have to overthink it. There's no friction or anything. So I solved for the kinetic energy in block 3m, 3.9 joules. Kinetic energy in block m, 11.8 joules. Energy is scalar, so we add them up, 15.7 joules. And then like our momentum bar graph, the energy in blue block is less than energy in orange block. Plug that into the website, everything's all good. Then I'll just move on to part C and D. Is the original energy in the spring or the cord? I said it was in the spring, which was correct, because we know that this elastic energy. The spring was kept closed, I suppose, by the blocks and the string being connected. But once that was released, then the energy could release from the spring, not from the string. Is the momentum of the system conserved in the bursting apart process? I said yes, because we have a frictionless surface, and our system is 2 blocks in spring. So that's about it. Just again, I'd like to address that this is a common misconception. with the energy and assuming that they're equal, which they are not. Make sure you include the direction for the momentum equation because that'll be important in setting everything equal to 0. And that's pretty much it. So thank you for watching.